So today we're going to go over 8.2 and the law of sines. So basically what I did is I kind of sketched a triangle. Let's call this triangle ABC. So this is triangle ABC. And what I did is I labeled the side lengths across from each angle as little b, little a, and little c, and so on. And then I drew an altitude right here, a height, that creates a right triangle, right? You guys all know that when you draw an altitude, you create a right triangle. And the reason we need this is because the sine, cosine, and tangent only work on right triangles. So everything that you use sine, cosine, and tangent for is for right triangles. So what happens, these are sometimes referred to as oblique triangles, but what happens when we don't have right triangles? That means we lose all of trigonometry. That means all of a sudden we can't use an entire field of math. Well, that's obviously not true. So one of the things we can do is we can still find a way to bring back in sine, cosine, and tangent. So the law of sines focuses on two main cases, okay? So we're gonna look at this triangle, and if I focus more on triangle ADB now, so you know, ADB like that, and I look at that, that is now a right triangle, and the sine of angle A, so here's angle A, the sine of angle A would be h, the height of that altitude, divided by c. And then if we did sine of C, sine of angle C, this angle right here, and likewise we did a different triangle, that would be, this would be for triangle, what would this be? CDB. We would get this. We would get the sine of C is equal to h over A, right? Yeah, because in this case, A would be the hypotenuse, so h over A. So what I now could do is I could solve both of these equations for h, and that would give me that C sine of A is equal to h and A sine of C is equal to h. But if those both equal h, then they technically could equal each other. So I set them equal to each other right here. And then once we have this, I could solve. I shouldn't say solve, but I could put the C's with the C's and the A's with the A's. So I'll end up with A over sine of A is equal to C over sine of C. Or you could also write it like this: sine of A over A equals sine of C over C. And we could do something very similar for sine of A over A and sine of B over B, or vice versa. But that means then that A over sine of A equals B over sine of B, but sine of A, or A over sine of A, also equals C over sine of C. So that means all three of them are equal, and this is what this law of sine states. It says that A over sine of A is equal to B over sine of B is equal to C over sine of C. And you can use the reciprocal of all of these at once as well, as long as each of them is the reciprocal. You know, you create a reciprocal for everything. So you could do sine of A over A is equal to sine of B over B. It really depends if you're trying to solve for a side length or for an angle. That's just how you decide which one to put on the top and which one on the bottom. So the law of sines we use for these two main cases, side angle angle or angle side angle, which basically talks about, you know, one side and you know two angles, okay? So if you know one side and you know two angles, hold on real quick. I think I just saw a mistake in my notes. Oh no, never mind, that's right. I just wanted to verify, Okay, so case one is side angle angle, or angle side angle. So one side is known and two angles are known. There's the second case, which is the harder case. This we could say is the most difficult. This is the most difficult case. That is oftentimes called the ambiguous case, where we are given two sides and one angle, but we do not know the angle, but it's not the angle that's in between the two sides. So we'll get to that in case three. So for case one, we identify it and we use the law of sines. So here, oftentimes they'll either say solve for the missing angles and sides, or they'll say complete the triangle. So it says angle A is 68.41 degrees, angle B is 54.23 degrees, and side A is 12.75 degrees. So I took a minute and I just wrote out this triangle right here. And I normally kind of draw it always the same, even if the angles are different, because it's too hard to draw it to scale. It would be nice if it was already pre-generated and given to you. So that might happen sometimes in the homework, but don't count on it for every single problem. Okay, so I just wrote this out, and this gives me an angle and then a side. So that's AAS, angle, angle, side. So that would be case one, just backwards, right? So what I'm gonna do is I'm gonna come over here and I'm gonna be solving, well, technically I can find angle C right now. So angle C is equal to 180 minus 68.41 degrees minus 54.23 degrees. So angle C equals 64.41, 180 minus 64.41 minus 54.23. And I get 61.36. Let me make sure I did my math right. So let's do 68.41 plus 54.23, 180 minus that. And I get 57.36 degrees. Oh, I wrote it, I'm sorry, I typed it in wrong on my calculator. So I would get angle C is worth 57.36 degrees. Okay, so let's put 57.36 degrees. So we technically know all three angles. So that's kind of the nice thing about case one, is you automatically just do a little bit of arithmetic and do 180 degrees minus the two angles. And that's why I went wrong. It's a 68 right here. And you would get 57.36 degrees. So we have all three angles now. In general, now that you know all three angles and you know one side, you can find the last two sides. So I'm just going to do B over the sine of B, which is 54.23 degrees, equals A, which is 12.75 divided by the sine of A, which would be 68.41 degrees. So now I'm going to just use my calculator. So I'm going to do 12.75 divided by the sine of 68.41. Hit enter. Make sure your calculator is in degree mode, by the way. And then I'm going to multiply this times the sine of 54.23 degrees. And I get 11.12, 11.125. So this is 11.125. So I'm going to round it up to 11.13. Okay, so 11.13 feet. Okay, now we're going to do the next one. We're going to do side C over the sine of 57.36. That's why it was important for us to find angle C real quick. And then I'm going to use A again, just because it's the given. Normally, I mean, I could do the same thing with B, but what if I had got B wrong? Then I'm going to get the last one wrong as well. So I always try to use the givens whenever possible to kind of hedge my bets. So then we're going to say 12.75 divided by the sine of 68.41 degrees. So now this would be C equals, so I'm just going to do 12.75 divided by sine of 68.41. And then it's going to be times the sine of 57.36. So this time I get, let's round off again, 11.55 if we round off. So 11.55 feet. So we have completed the triangle. We have found all three angles and all three sides using the law of sines, okay? So let's take a look at another one. Let me have you guys pause the video. So try this one, set this one up. I wrote the triangle out for you. Again, we have angle, angle, side, which is case one. So pause the video and see what you guys can do on this one. Okay, so hopefully you're back and you now have B is equal to the, B over the sine of B, which is 81.8 degrees, and that should equal 42.9 divided by the sine of 32 degrees. So when we do this on our calculator, 42.9 divided by the sine of 32, hit enter, then multiply this by the sine of 81.8 degrees. And I get approximately 80.1 centimeters. Oh, I think this is in centimeters, by the way. Centimeters, so this is 80.1 centimeters. Now, technically, if I want to find angle C is 180 minus 32 degrees minus 81.8 degrees. So 180 minus 32 minus 81.8. So I should get 66.2 degrees. So that's another easy gimme right there. Okay, so now I have to find side C, and that's going to be the sine, C over the sine of 66.2 degrees is equal to, once again, I'm going to use A, 42.9 divided by sine of 32 degrees. So then C should equal 42.9 divided by the sine of 32, enter, and then multiply by the sine of 66.2 degrees, and I get 74.07 centimeters. Okay. Oops, let's round off to 1 decimal place. So let's do 74.1 because the other ones are all 1 decimal, so I should kind of match. So that's basically case 1. That's the easiest case. Now let's move on to the harder case, side-side angle. So some things to keep in mind, that 3 angles have to add up to 180. If one angle is obtuse, the remaining 2 angles must be acute, meaning smaller than 90. And the largest side is always opposite the largest angle, and the smallest side is always opposite the smallest angle. So the reason this is a more difficult problem is because we have a couple of weird scenarios that can happen, okay? So let me take a look at this one. So this one is, let me see, we have an angle and then a side and then a side, okay? So this would be angle, side, side, or side, side, angle. So this is different than this one, which was angle, angle, side. So we're given 2 angles in this one. This one would be angle, angle, side. But in case 2, we're given 2 sides and an angle, but the angle is not in between the 2 sides. So the case where it's side, angle, side, that's actually law of cosines, right? So we're going to deal with this one now. This is called the ambiguous case. So when we run into this one, basically you have to be a little bit more careful. I set it up for you where I have the sine of 37.6 divided by 3.4 is equal to the sine of C, which is unknown at this point, divided by 12. Okay, so this time I left the C on the signs on top because I'm going to be solving for an angle. Okay, so now this is going to become 12 times the sine of 37.6 degrees divided by 3.4, right? And that should be the sine of C. So here becomes the problem. If we plug this in our calculator, we do 12 sine of 37.6 and then divide it by 3.4. I get 2.15-ish, okay, is equal to the sine of C if we round off. Now here's the problem, okay? Here, oops, this is actually should be what, 2.2, 1 decimal place. So here's the problem. Can the sine of an angle ever be over 1? It can't, so this is impossible. So 0 triangles. So there are no triangles that can be completed in this fashion. So this is the ambiguous case, can have 0 triangles, we can have 0, 1, or 2, and we have to check each time. So whenever you run into side-side angle or angle side-side, basically just think of the bad word. That means something bad's about to happen, okay? So we come over here and let's try this other one. So in that problem, it was impossible to build a triangle. Let's try this one. So for this one, I'm going to try to build a little triangle. Let's see here. So let's say that we have, oh, I don't know. Again, I'm just drawing it just to draw it. So angle B is 31.3 degrees. Side A is 38.6. Side B is 32.2. And we don't know C and we don't know A, or angle A and angle C. So we have angle side side, or side side angle, whichever way you prefer. So what we're going to do now is we're going to set up the sine of, let's go with A, over 38.6 is equal to the sine of B, which is 31.3 degrees, divided by 32.2, okay? So now I'm going to get the sine of A is equal to, so now we do sine 31.3, sine 31.3 divided by 32.2 times 38.6. And I get 0.6227. So the sine of A is worth 0.622, let's say 8. Let's round off to 8, okay? You could say 0.62277 if you wanted. I got 77. But it's technically, if you want to round off to 4 decimal places, I think that would be fine. Double check in the homework how far they want you to round. But here's the problem. What I have to do now is I have to solve for A. This does not match any of the special angles that I know. So what I'm going to do is I'm going to arc sine both sides. So I'm going to say sine inverse of this and sine inverse of this. So that will now give me, let's see here, angle A is worth, second function arc sine. I'm just going to use the 0.66622775689 that's on my calculator. I'm just going to plug that in. And I get 38 point, let's say 52 degrees. Okay, how many decimal places? Oh, they're only using 1, so let's just use 38.5 degrees. So we now found angle A. But if we know angle A, we already know angle B is 31.3. So let's call this A1, B1, and we know angle C1 is equal to, let's see, 180 minus 38.5 minus 31.3. So we get 110.2 degrees. And now we know A, B, and C. So now we can find A sub 1, B sub 1, C sub 1, and you'll see why I'm using subs in a second. Okay, so now what we can do is we already know that angle or side A is 38.6. Okay, now we should be able to find, did they give us another side? Oh, B is 32.2. So now all we need to do is find C. So I'm going to say C1 over the sine of 110.2 degrees. Geez. Equals, and now I'm going to use the given angle B, the 32.2 over sine of 31.3. Again, I always try to use the givens. So let's do 32.2 divided by the sine of 31.3, and we're going to get 61.98. So let's round that off. Oh, oops. And then we're going to multiply that by the sine of 110.2. So I get C1 is equal to 58 point, I guess 168, but we're going to say that 58.2 degrees. Yeah, they're using that. So I can now say 58.2 degrees. Oops, sorry, that's not degrees. That's a side length. Sorry about that. 58.2. So I have completed a triangle. But here's the problem. Way back here in this step, when I said the sine of A was worth 0.6228-ish, if I round it off, it was 0.622775, blah, 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 blah. Technically, if you think about your unit circle, where was sine positive? Well, sine is positive here, and sine is also positive here. So I have to find and see if there's another angle that would have created that similar value. So here's what you have to do. You have to say, okay, so angle A we found. So let's see over here. Let's go over here. We found angle A to be 38.5 degrees. So what I have to do is I have to say, well, 180 minus angle A, which would be 38.5 degrees, would give me 141.5 degrees, okay? So what we're saying is, here's angle A, and that's 38.5 degrees, okay? And then here's 141, the same sine coordinate. It would have the same sine value. This is 141.5 degrees. Both of those could be correct answers. So we have to see if there's room for a second triangle. So we're going to say A sub angle, oops, this will be angle A sub 2 would be 141.5 degrees. B sub 2, we already know B is given, right? B is 31.3. So we have to see if there's room for an angle C. So what I'm going to do is so if you do the subtraction, you do 180 minus 141.5 minus 31.3. If you get a negative number, or if there's not enough room, then you say there is no second triangle. But in this case, I get 7.2 degrees. I actually get enough, there's enough leftover angle to create a triangle. So that means I now have to find my new side C. So for this case, there were two triangles. If we had built these two, or I mean, used the given and then built the other one, and then there wasn't enough room for a third angle, then we would just stop and say there's only one triangle. But because I was still able to write down the third angle, that means that there is two triangles. So now I have to go and I say, well, side A was worth 38.6. Side B was worth 32.2. So now I have to find my new side C. So then I'm going to say that C2 over sine of 7.2 degrees is equal to 32.2 divided by 31.3 degrees. So then C2 equals, so I'm just going to do my calculator. Oops. C2 equals 32.2 divided by, oops, why did I do that? This is a sine of 31.3 degrees. Sorry about that. Ooh. Yeah, okay. So then 32.2 divided by the sine of 31.3 equals, and then I'm going to multiply that by the sine of 7.2 degrees. And I get 7.7682, so on and so on. So I'm going to say C2 is equal, we're going to round this guy off to one decimal place. C2 is equal to 7.8. So we have our second possible triangle from the restrictions given. So this has two triangles. Okay. So the thing you guys really have to look out for in this case is this right here. You really have to look out for this picture. You should draw this. Whenever you find the sine and then find the arc sine, there was a second angle that could have given you that same sine coordinate. Okay. So let me see, I'm almost have to start my next class. So let me do one more for you. Let's see if I got a nice one. Okay, so this one right here. So this problem right here, oops. So I give you C equals 63 degrees, 10 minutes, C equals 31.7, and B equals 23.7. So this is just from your book. This is just trying to be fancy. We're just going to call this C equals 63 and 1/6 degrees. C equals 31.7. Because think about it. If you wanted to convert that, wouldn't you just do 10 divided by 60? So it's going to be 63 and 1/6 degrees, which is 10 over 60. oops, 31.7, and B equals 23.7. So let's see what case this is. So once again, I just draw like a rough sketch. This is my A. I'm running out of time, so I'm going to be late to my other class, so just bear with me. Okay, so we have that, and it's not a right triangle. So we know, we don't know angle A. We know angle C is 63 and 1/6 degrees. We don't know angle B. We know side C is 31.7, and we know side B is 23.7, okay? So we have angle side side, or side side angle, side angle, depending on how you look at it. So that means it's case 2. Right? So what we're going to do is we're going to use the law of sines, and law of sines says that we can find the sine, sine of B. And remember, you always have to use, for your very first step, the angle that has the side length opposite of it. So we're going to use sine of B over 23.7 equals the sine of 63 and 1/6 degrees divided by 31.7. So we're going to have the sine of B is equal to, now I'm just going to do sine of 63 plus 1 divided by 6. Okay, divided by 31.7, and then multiplied by 23.7. So I get, let's see here, 66, did I mess this one up? 66.713. So 66. Okay, so I get that. Now the thing is I'm going to arc sine. So let's do second function arc sine of second function answer. And I get B is equal to 41 point, let's say 8. I'm just going to say 41.8 just to kind of round off. How many decimals are they using for angles? Let's just use 41.8 degrees. So we now know that angle B is 41.8. Now let's find, let's see if there's a second triangle. So check for second triangle. Okay, so what we need to do is we need to think about the unit circle. This right here is 41.8 degrees. So that means there's a matching one over here. So I'm going to do 180 minus 41.8, and I get 138.2 degrees. Okay, now here's the problem. The total has to be smaller than 180. So if my possible angle B is equal to 138.2, what's my angle already given? We already know that C2 has to be 63 and 1/6. So if I do 138.2 plus 63, let me fix this real quick. 63 plus 1 divided by 6. I'm at 201. So if I just do B2 plus C2, I'm at 201 degrees, right? 201.36. So that means that there is no room for angle A to exist, okay? So that means only one triangle, okay? So what we're going to do is we now know angle B is 41.8 degrees. So now what I'm going to do is I'm now going to do the sine of, let's see here. Ooh, we also know, we now can find the last angle A. So we're going to do 180 minus 63 plus 1 divided by 6 minus 41.8, and we're going to get angle A (180 minus 41.8 minus 63 and 1/6 degrees). So angle A is worth 75.0. It's 0.03, but I'm just going to say 75.0 degrees. So we now have angle A equals 75 degrees. We have angle B equals 41.8 degrees. We now have angle C is equal to, they already told us that one, 63 and 1/6 degrees. So now we just need side A, B, and C. Well, we know that B is 23.7, and we know C is 31.7. So all I have to do is I have to find, sorry, there's a helicopter, guys, bad luck. Okay, so I'm just going to take the angles that I know with the side lengths that I'm trying to find. So I'm trying to find side length A, divide it by the sine of 75 degrees. Then I'm going to do C, which is 31.7, and I'm going to divide it by the sine of 63 and 1/6 degrees. So then A equals, and then I'm going to multiply it by the sine of 75 degrees. And I get 34, I hope that's right, 34.3, yeah, 34.3. So 34.3 after I round off. So I was able to find my triangle, one triangle only. So that's all three scenarios, no triangle, two triangles, or one triangle. You always have to check. It comes down to this right here and checking to see if there's enough room. Now, if this was anything less, if this was less than 180, let's say if B2 plus C2 was like 174, then there's enough room for a third angle, and we have to go and double check everything. That's going to do it for this video, guys. I'm out of time. I got to teach another class, but hopefully this helps you get started on 8.2. Thanks for watching.